Good morning, I am Gianluca Bianchi and I will present the work on recalibration of damage equivalent factor for fatigue assessment of road bridges, did in collaboration with Professor Alain Nussbaumer and José Oliveira Pedro and Mr. Colan Vaccari. In order to enter in the detail of the presentation, we start with a brief introduction. On the right of the slide we can see some typical details, and on the left we can see the Wheeler curve of the corresponding details. We have two slopes. The first is correspond to the limit of 5 million of cycles, and this is the constant amplitude fatigue limit. The second one is the cutoff limit as 100 million of cycles, and all the details are classified at the corresponding value at 2 million of cycles. The hero code gives three different verifications. The first one is the fatigue limit, which the maximum stress range must be inferior to delta sigma d. The second one is the total damage. That is complicated to apply because it's necessary to have all the stress history of the detail and do the calculation with cumulation of all the cycles. And the third one is the lambda method. That is a simplified method that put in relation the second method with the fatigue load model tree. That is a set of two lorries that run on the inference line to calculate the maximum and minimum stress to have finally the delta sigma q fat. This presentation is based on the lambda method that is composed by 4 factors and a lambda max that represent the upper bound that can be reached by the combination of the 4 factors. Lambda 1 represents the damage of traffic and put in relation the fatigue load model tree with the real traffic given by the inference line, and a parameter to obtain that is the critical span length. The lambda 2 is given by the volume of traffic. It depends on the number of vehicles and the average vehicle weight. The lambda 3 depends on the bridge life, and the time of reference is 100 years. And finally, the lambda 4 depends on the traffic on multiple lanes. And the main problem of the lambda method is that we have a big dispersion in the values of lambda because the current curves are based only on 4 cases, and the rules for finding critical length are not clear and don't cover all the cases. And finally, the most recent simulation proves that the current course doesn't correspond to the reality. The method to obtain the new lambda course is quite easy. On the right, we calculate the delta sigma given by the fatigue load model tree, and on the left side we calculate the delta sigma given by the real traffic simulation. So we pass through the inference line a set of lorries with parameterized traffic. We obtain a stress history. We classified in cycles this stress history, and then we moved on vertically the curve of resistance of the detail to obtain a damage equal 1, and the delta sigma corresponding to 2 million of cycles correspond to the delta sigma of this simulation. The ratio between the real traffic model and the fatigue load model is the corresponding lambda 1 factor. As a first parameters of our simulation, we introduce a set of 45 types of inference line with a span range between 2 meters and 1000 meters that generates in total more than 2000 inference line. Then we created a simulated real traffic that is based on the vehicles of fatigue load model 4 with a distance between the vehicles that is given by a Davenport law. And we introduce also percentage of congested traffic, and that gives simulated real traffic that can help to study the behavior of each parameter. And finally, to validate this real traffic, we introduced different WIM from Finland, Netherlands, and Switzerland that are very different type of traffic in average vehicle load and average vehicle distance. Once the algorithm is ready, we needed to validate it, and for do that we introduce the parameters of the simulation of Sedlacek and Merzenich for lambda max in our simulations, and we see that the corresponding is very good. And we did the same things for the simulations of Joan Mylar. We introduced the A16 WIM traffic and the fatigue load model proposed by him, and we see that our code gives the results quite similar to the results he had. So from this simulated real traffic, we had the possibility to change some parameters to see the behavior of the curves, such as the type of lorries, the percentage of empty lorries, or the congested traffic. So finally, we have clear views that was missing in the previous version of the simulations. And one of these comparisons that we did is the fatigue load model to use. In gray, we can see the one that we used with a single lorry, and in red is with the second lorry as the actual fatigue load model tree. We see that the use of the second lorry is not so useful because complicate more the method for the engineers and complicate the shapes of the curves. So we decided to remove this from the final version of the course. We study also the slope of the SN course, and we see how it works for these four typical cases. And finally, we use the 3 and 5 slope because it is the one that is have the most type of details. We checked also the lambda 2 formula, and in this case we can see in rows the application of the lambda 2 formula to the long distance vehicles traffic, and we see that correspond properly to the red course that is the local distance traffic. We did some tests also for the lambda 3 formula. In this case we can see the application of the lambda 3 factor on a bridge life of 100 years to see the correspondence for 50 years bridge life. And last point to consider for the proposition of the new curves is the definition of the critical length L lambda. We simplified a lot the rules to define it, and now the support critical length is just the average of the two adjacent spans, and the mid-span critical length is just the length of the reference spans, with the exception of the intermediate reaction and the two span support moments with equal spans that have now the sum of the two adjacent spans. With this method, we define the new course, and we reduced a lot of the dispersion. So now the new method is easier, but also more precise. Finally, we put together all the simulation and we divided it in 4 graphs with midspan or support, bending moment or shear forces. We obtain the fractal at 95% of the course in blue, and from that we simplified a lot. We find some equation and some easy function to define the new lambda 1 course proposition. And finally, once we have the new lambda 1 course proposition in red, we put also the WIM results with the different type of traffics, and we see that the most relevant traffic is the A16s in Netherlands, while the less important traffic is the ones of Sweden, of course, because of the distance between vehicles. And so these are the new lambda 1 course that we propose for the new version of Eurocode. And we did also the same work for lambda max course, as we can see in this graph in continuous black. And finally, we did an error analysis between the proposition and the results of weighted motion measurements with the fractal of 95%. We see that all the curves are mostly on the safe side with 5% of margin. And in blue we can see the actual curves of Eurocode that are sometimes too on the safe side and sometimes too not on the safe side. And this is the zoom on the two curves, so the proposed one and the Eurocode, and from 10 meters to 80 meters of span length. And we can see that for mid-span shear forces, the Eurocode is not at all on the safe side, while our curves are always on the safe side with a little bit of margin. So as a conclusion, here we have a resume of the main parameter that we introduced in confront of the previous version. And the most important are the use of congested traffic and the use of multiple vehicles on the same influence line, and the division by axles of the vehicles. And the main points that we introduce in this new version of the course is the simplified fatigue load model tree that make easier the work for the engineers. An updated simulated real traffic, FLM4, that is already classified in the Eurocode. Simplified definition of the critical lengths. And we cover more span lengths that was the lack of the previous course. And of course the simulation are now based on more than 2000 influence line. And another good point for simulation is that it's easy to recalibrate the simulation with the weighted motion measurements. So every country can define their own lambda 1 course, or just verify if they work properly on the proposed one. So that's it, and thank you for your attention.